Hello, good morning, Siplan team. I think things are going well. Okay. Myself, Padmalaya Palo, did my master's in organic chemistry and I have a bachelor's in education degree. I would like to join the Siplan team as an online chemistry tutor. For this, I would like to give a demo on the chemistry topic, that is atomic structure and chemical bonding. My dear students, good morning. Before going to the topic, make sure that your background is away from noise. Have your notepad and pen. Keep the mobile in a landscape mode. Okay. Okay. Let's start the topic. Yeah. Today's our topic is atomic structure and chemical bonding. First, it goes with the introduction of atom and discovery of electron, protons, and nucleus. Today we are going to learn nature of matter, Dalton's atomic theory, drawbacks of Dalton's atomic model, definition of an atom, discovery of an electron and proton, plum pudding model of J.J. Thomson, Rutherford's atomic model and its drawback, Bohr's atomic model, and discovery of neutrons. Next, in the previous classes, we have studied that everything that have mass and occupies space is called as a matter. Next, nature of matter. There are different beliefs about the nature of matter. In the 6th century BC in India, an Indian philosopher Maharshi Kannada was the first to suggest that matter is made up of tiny particles called anu, which will be further divided into smaller particles called paramanu, that is indestructible. What is anu? Anu have an independent existence. Paramanu, it is the smallest particle, does not have an independent existence, combined with other paramanus to form a bigger anu. Democritus, the Greek philosopher, called paramanu an atom. He called it as paramanu as an atom. That comes from the Greek word atomos, meaning indivisible. Later, it was suggested by John Dalton that all kinds of matter are made up of extremely small particles called atoms, and different types of atoms contribute to different types of matter. Dalton's atomic theory next. According to him, all matter is made up of small and indivisible particles called atoms. That is, atoms can neither be created nor be destroyed. Atoms of the same elements are alike and have the same mass. For example, carbon is an element made up of carbon atoms only. As we said that atoms of same elements are alike and have the same mass. So when you take the atom of a carbon, it is simply a carbon. So carbon is made up of only carbon atoms, but it is not mixed up with any other atoms. So it states that atoms of same elements are alike. They are same and have the same mass. And another example, copper is an element made up of copper atoms only, but not with copper with carbon or not the carbon with copper. That is, atoms having atoms of the elements made up of same atoms. Thus, the element is a substance which is made up of only one type of atom. So, here the things which are made up of only one type of atoms are called as element. Thus, the element is a substance made up of only one type of atoms. Atoms of different elements combine in fixed volume ratio to form compounds. Atoms are smallest unit of the matter that can be take part in chemical reaction. Okay, so here atoms of different elements combine in fixed volumes. Like one atom of carbon combines with some fixed amount, fixed whole number ratio to form compounds. Atoms are the smallest units of matter that can take part in chemical reaction. Next is the compound. When two or more elements combine chemically in a fixed ratio is called as a compound. When two or more elements combine in a fixed ratio is called as compound. For example, you take water. Here, water is forming by the combination of hydrogen and oxygen. Your H is an hydrogen and O is an oxygen. The fixed ratio is nothing but the two atoms of hydrogen combining with one atom of oxygen, or two hydrogen elements combining with one element of oxygen to form a compound, that is the water molecule. So the ratio is 2:1 because your two hydrogen atoms are combining with one oxygen atoms to form a single water molecule, which is called as a compound. Next, drawbacks of Dalton's atomic theory. According to Dalton's atomic theory, atom is indivisible. He stated that atom is indivisible. This was proved wrong as an atom can be subdivided into subatomic molecules. According to Dalton's atomic theory, atoms of the same element are alike and have the same mass. This was also proved wrong as atoms of the same elements can somehow differ from each other. These are the two drawbacks of Dalton's atomic theory. Atom consists of subatomic particles, that is, they are made up of charged particles. As we said that atoms consist of some other subatomic particles, those subatomic particles are charged particles. This was explained by J.J. Thomson, showed that existence of these charged particles and discovered negatively charged particles and named them as electrons. So J.J. Thomson discovered some negatively subatomic particles or negatively charged particles in the atoms and named them as a electron. The discovery of proton is credited to Ernest Rutherford, that is positively charged particle in an atom. So the next to the subatomic particle which was discovered by J.J. Thomson was an electron, and next to it Ernest Rutherford discovered another subatomic particle which is charged one, and he named it as a proton. So the proton, which is another subatomic particle, discovered by Rutherford. Later, James Chadwick discovered neutrons that are neutral. And the last subatomic particle discovered by James Chadwick was the neutron. And he said that neutron does not have any charge. It is a neutral charge. So, J.J. Thomson discovered the electron, which is negatively charged. Rutherford discovered proton, which is a positively charged. And James Chadwick discovered neutron, which has no charge. Electrons, protons, and neutrons are called fundamental particles of an atom. These subatomic particles are otherwise called as fundamental particles of an atom. These particles are the building blocks of all atoms of the element. So all the atoms of an element are consisted of these particles, subatomic particles or the fundamental particles. Let's go to the definition of the atom. An atom is the smallest particle of an element that exhibits all the properties of element. Okay, atom is the smallest particle of an element that exhibits all the property of an element. For example, grind a piece of copper into small pieces. All small pieces show the property of copper only. Break up into different fine particles which still show the properties of the copper. Which comes when the particles cannot be further subdivided into particles exhibiting properties of copper. These indivisible particles are the atoms of copper. Okay, whenever you take the smallest element like copper is an element, you grind it into small pieces. Whenever you have grinded into small pieces, those small pieces exhibit the property of copper only, but not the property of other elements like carbon or hydrogen. Further, you divide it into fine particles, then also it exhibits the property of copper only. Until you divide those particles where it gets into a state that the atoms cannot be divided further. Even then also it exhibits the property of copper but not the other elements. This is called as the unit used to describe the mass of an atom is AMU. AMU stands for the atomic mass unit. 1 AMU is equal to 1.66 into 10 power minus 2. Students, I hope you are noting down. As we have studied that electrons, protons, and neutrons are called the fundamental particles of an atom. So let's now know to understand how these fundamental particles are discovered. Discovery of an electron. A British scientist, William Crookes, noted when a high voltage is supplied to tubes filled with gases at very low temperature, the gases which are ordinary non-conducting became good conductors of electricity, and charged particles begin to flow from cathode to anode in the form of rays. So it is voltage, the gases which are ordinary non-conducting, initially they are ordinary and non-conducting, became good conductors of electricity. Became good conductors of electricity in sense they started passing electricity through them because they consist of charged particles. And charged particles begin to flow from cathode to anode. From cathode to anode in the form of rays. The charged particles are the electrons, protons, started begin to flow from cathode to anode. Means negative charge to the positive charge. Cathode is a negatively charged electrode, and anode is a positively charged electrode in the form of rays. Yeah, students. Here I would like to stop it.